Hello friends, myself Rama. I am working as assistant professor in Mlritm college. My concept is polymorphism. Today I am going to discuss about the polymorphism concept in C++. Let us see what is polymorphism. It is one of the basic concepts of object-oriented programming. Polymorphism is a Greek word. The meaning of this polymorphism is many forms. So here poly means many, morphism means forms. So it is also called as many forms. Polymorphism means a single function can perform multiple types of operations in multiple ways. The types of polymorphisms are two types. First one is compile time polymorphism and the second one is runtime polymorphism. Here we can achieve the compile time polymorphism in two concepts. One is function overloading and the second one is operator overloading. Here we can achieve the runtime polymorphism by using the virtual functions. Here the virtual functions are used in function overriding concept. So this function overriding is implemented by using the virtual functions. This compile time polymorphism, it is also called as static binding. Binding means linking. The runtime polymorphism is also called as dynamic binding. Now let us see one by one what is static binding and what is dynamic binding. The first one is static binding. It is also called as compile time. In static binding, the function call is linked with function definition at compilation time. So this compilation time is nothing but static time. So here the function call and the function definitions are linked at the time of compilation. That's why it is called as static binding. It is also called as early binding. Means here when we consider the compile time and run time, the compile time will come first. First we can compile the program, then we can run the program. At the time of program compilation, this function call is linked to function definition. That's why it is called as static binding and also it is called as early binding. The execution time of static binding is faster than dynamic binding. Now let us see the dynamic binding. It is also called as runtime polymorphism. The dynamic binding is a connection between the function declaration and the function call. Here in dynamic binding, the function call is linked to function declaration. But in static binding, the function call is linked to function definition. Okay, when we consider the execution time, the execution of dynamic binding is slower than the static binding. So what is why we are using dynamic binding means the static binding, it contains some drawbacks that are overcome by using the dynamic binding concept. Now this dynamic binding is very flexible. It avoids the drawbacks of static binding. Now here in static binding, we use the two concepts. One is function overloading and the second one is operator overloading. But in dynamic binding, we can implement the function overloading, function overriding. Function overriding is used here. Override. Now let us see what is function overloading and what is function overriding. The first one is function overriding. Overriding. Now let us see function overloading. Function overloading is defined as the process of having two or more functions with the same name. In a single program, we are using the same function name multiple times, but that multiple functions are differentiated in the form of parameters. Means that multiple functions contains different types of parameters. So in function overloading, the function is redefined by using either different types of arguments are different number of arguments. So here in function overloading, the same function is used multiple times, but in multiple functions we can use the different types of parameters and a different number of parameters. By using the different types of parameters and different number of parameters, we can differentiate the functions in function overloading. Let us see the example. So here in this example, I declared only one class, that is class A. Now here I am using only one function display for multiple times. In the first case, display, it contains only one parameter, that is integer. Second time I am using the same display function but two different parameters. First one is integer and the second one is float data type. In the third case, the display function contains only one parameter, that is float. Here in the first case and third case, the same function is used with only one parameter, but in the first case, this function contains integer parameter. In the third case, I am using the float data type parameters. So here the first one and third function, these two are differentiated by using the type of the parameter. In the fourth case, so I am using the same display function with two parameters, integer and float. But in the second case also I am using the two parameters, integer and float, but the order is different. Here the order of the parameter is integer first, then float. But in the fourth case, the display function, it contains the parameters order is float and integer. This is the first one. Second function, third, fourth one. So this is the fifth one. In the fifth time, same function name display with the three parameters. All the three parameters are integers only. So when we consider this example, a single class contains the same function 5 times. So same display function is repeated 5 times, but in the 5 cases, the function contains different types of parameters. Now go to the main function. The program execution begins from main function. First here, object is created for the class A, obj, object name, obj.display. Here we are calling the display function by using the object 5 times, 1, 2, 3, 4, 5 times I am calling the same display function with different parameters. Now let us see the execution. First, display function, calling the display function with only one parameters. Then control goes to the first function, display. The function name is same and the number of parameters are matched, that is 1. Here what we are passing? Integer. This function also contains integer. So that value is passed to variable A. Obj.display means it directly calls the display function and it verifies the number of parameters and the data type of the parameters and the order of the parameters. If everything is matched, then that function will be executed. If the function call is not matched with the function definition, then the control goes to the second function. Okay, this process is continuous. Next, here we will get the output A value equal to 10. Next, after completion of first one, we are calling the same display function by using the single parameter. Here the parameter data type is float. Now the control goes to the first function. The function name is same but the parameter is different. Here it contains integer. Here what we are passing? We are passing float value. So that function call is not matched with this function definition. Then it goes to the next one. Here the number of parameters are different. Here this function definition contains 2 parameters, but here we are passing only 1. It is not matched. Then it goes to the next function. Here the function name is display and the parameter value is float. Here the data type of the parameter is matched and the number of parameters also matched. Then that value is passed to the variable b. So what we are passing? 20.2. Now the b value is 20.2. It is a floatware. Next, after the execution of that function, the control again calls the display function by passing the two different values, two parameter values. The first one is integer and the second one is float value. Now the control, it verifies the one by one function. The first function, it does not match because the number of parameters are different. Then the control goes to the next function. The number of parameters are same 2, but it also verifies the order of the parameters. So what is the first two value? Integer, and the second value is float. The order is integer and float. Then here it verifies the order of the parameters, integer and float. These two are matched. Then it executes. The value a is passed to, the value 3 is passed to a variable. The value 6.5 is passed to b variable. Then it display a value equal to 3 and b value equal to 6.5. After the completion of this function, again the control goes to the main function. Then it calls the display function by passing the two values. Here the parameters are 2, but the order is float and integer. Now the control first goes to the first function. It is not matched. Then it goes to the second function called function definition. It is not matched. Then it goes to third one. It is not matched. Then it goes to fourth one. It verifies the function name and the number of parameters, that are 2, and also it verifies the order of the parameters. So order is float comma integer. So everything is matched. Then the first value 4.5 is copied to variable a and the second value 8 is copied to variable b. Now here we will get, so first b value, NC out first b value, it is equal to 8, and the next a value, it is equal to 4.5. Next, display of 2, 5, 10. We are calling the same function with 3 different parameters. Now that is matched with the last function definition. The first value 2 is copied to variable a, 5 is copied to variable b, and 10 is copied to variable c. Here we will get a value equal to 2 and b value equal to 5, c value equal to 10. Okay, here the display function name is same, but that function is differentiated by using the number of parameters and the order of the parameters, data type of the parameters. Now this is called function overload. Here we are overloading the same display function by using the different types of parameters. Note, in the above program, display function is overloaded. The same function name display used 5 times. In 5 different cases, the display function, it performs 5 different types of operations. So function name is same, but the types of operations are different. This is called as polymorphism. The next one is function overloading. In function overloading, it is used to achieve the static binding, compile time polymorphism. Next, we can achieve the runtime polymorphism, that is also called as late binding. So we can achieve that by using the function overloading. Okay, here function overloading is different, function overriding is different. In function overloading, the function name is same, but the parameters are different. Here all the functions are used in a single class. But when it comes to function overloading, here we can use the inheritance concept. The inheritance, what is inheritance? What are the types of inheritance? Or with examples are discussed in the previous video. Next, in function overriding, if derived class defines same function as defined in the base class. So base class, derived class, okay, these two are the related words which are used in the inheritance. derived class is nothing but child class. Base class is nothing but parent class. So child is derived from the parent. Child is derived from the parent. So here what is the meaning of this sentence is the same function used in parent, the same function is used in child also. In function overloading, we are using the same function. The function display used multiple times within the same class. But when it comes to function overriding, we are using the inheritance concept. In this case, the parent and child, both the classes are having the same function name. Here we are overriding the functions. The child class function, it overrides in the parent class. So it is known as function overriding. The same function is used in parent and child class. The number of parameters, data type of the parameters, order of the parameters, everything is same in both the classes. So it is used to achieve runtime polymorphism. So let us see the example here. Class A, it is a parent class. Now it contains two functions. One is add and the second one is sum. Here the access specifier is public, means we can easily access this add and sum functions outside the class also. Next, declare child class, that is B. Now this child class is derived from the parent class A. This is A, parent class, and this is B, child class. It is derived from the parent A. Now here this child class also, it contains the same functions add and sum. So when we observe this program, in parent and child, the function names are same and the signature of the function is also same. Means the parameters are also same in both the classes. So same add function is used in child and parent. The same sum function is used in parent and child. Here we are overriding the add and sum functions. Same type of functions with no difference. Okay, used in both parent and child. This concept is called as function overriding. Note here, add and sum functions are defined in both base and derived classes. It is called as function overriding. So this is the main function. In this main function, two objects are created. One object for class A and the object 2, second object for class B. Now let us see very carefully. A is a parent class. One pointer is declared for the parent class. Now PTR equal to object, address of object, means in this pointer, it points to the object 1. So this pointer is declared especially for base class and the base class object address is copied into that pointer. Now by using this pointer, we are calling the function add and sum. Here what is object 1? Object 1, it is a reference to class A. So that address is copied into variable pointer PTR. Now by using this PTR, we are calling the function add and sum. This control directly goes to the parent class and it executes these two functions. Here we will get the output. This is add function in base class. This is the first output. PTR pointer calls the add function from the base class. So here we will get this line as the first output line. Next, we are calling the sum function by using the PTR. Then automatically we will get this line as the second line output. This is sum function in base class. This is the second line. This is sum function in base class. Next, PTR equal to address of object 2. Now here we are copying the address of the second object to the pointer variable. Next, the address of object 2 is now placed in PTR pointer. By using that pointer, we are calling the add and sum function. But here add and sum functions are overridden. That's why we will get the same output value. This is add function in base class only. Next line, by calling the sum function, here we will get the output. This is sum function in base class. Here we will get this output. This is add function in base class. This is sum function in base class. This is add function in base class. This is sum function in base class. But here, why we are not getting these two output values? Even though we are copying the address of the second object in PTR, when we call add and sum function, the control directly goes to parent class only, because these two functions are overridden. So, by copying the address, we are getting the base class output only. We are not getting the child class address. So, always this pointer, it calls the base class functions. Base class function add and sum only. It does not call the child class functions, because this pointer is created for class A. Even though we are copying the address of the object 2 in pointer, this pointer, it always calls the parent class method. It does not calls the child class methods. So here this problem is overcome, or this problem is solved by using the virtual functions. So here the function overriding is used to implemented for runtime polymorphism. But here we are getting the output always this class, base class output only. We are not executing this child class functions. So if you want to get this output also, if you want to execute these two functions after overriding the functions in base class, we have to use virtual functions concept. So here, when we observe this output, we are calling the add and sum functions twice. But in the first case, object 1 address is copied into the PTR. In the second case, address of object 2 is copied into the pointer PTR, even though we are getting the base class output only. We are not getting the child class output. So, in this function overriding, we can overcome this drawback by using the virtual functions concept. Now, let us see what is virtual function. A virtual function is known as a member function that is declared within a base class and is redefined in derived class. Means, in the previous example, we are using the same functions add and sum in base class and child class. But when we use the virtual concept, the virtual function is used in base class that is redefined in derived class. Means first we have to use the virtual functions concept in base class only, but that virtual functions are defined in the child classes. So what are the rules for virtual functions? The first one is virtual functions are declared with the keyword virtual. The resolving of a function call is done at runtime. For runtime polymorphism, we are using the virtual functions concept. The virtual functions cannot be static. The fourth point is virtual functions should be accessed using a pointer or reference of a base class type to achieve runtime polymorphism. So when we observe the previous example, here a pointer variable or a reference is created for the base class. Okay, that is written here. Virtual functions should be accessed using a pointer variable, for example, PTR of base class. Here, what is the base class? A is a base class and B is a child class. This pointer is created for base class only. So, here we use the same concept in virtual functions, but we use the keyword, we had to use the keyword virtual in base class before the function name. If we have same function used in both base class and derived classes, and if we want to execute the function, it always executes base class function. Okay, this concept is discussed in this example. Here always we are getting the base class only. Here we are not getting derived class output. So if we have the same function used in both and base class and derived class, here these add and sum, these two are same functions which are used in base class and derived class. And if you want to execute the function, it always execute the base class function. That's why we are getting here, when we observe this output, always we are getting the base class output only. If we want to execute derived class function, we have to use virtual keyword. Virtual keyword for base class function. So, the same program is used, but we had to use the keyword virtual. It is small. Use virtual keyword before the function name in the base class only, not in derived class. The syntax is virtual keyword, public access specifier, and the function name sum. Let us see the example. The same example is explained here also, but there is a difference. Here I am using keyword virtual. So, class A, it is a base class, and class B is derived class or child class. In base class, there are two functions, add function and sum function. In derived class, there are two functions, add and sum function. Here, same function names are used in base class and child class. But in the previous example, always we are getting the base class output only. But when we use the virtual keyword before the function name, then the control executes the child class function. It means when we use the keyword virtual before the function, it will be executed only one time. So, this add function is declared as virtual, then it is called as virtual function. But when we observe this sum, it is not a virtual function, it is a normal function. So, here the sum function is overridden, but not add function. Here the add function in child class it is a normal function, but a add class in a base class, it is a virtual function. When we use the keyword virtual, that function will be executed only one. If you try to call second time, the control sends the control to the child class. It does not execute second time. But in the previous example, always when we call this add and sum, the control always goes to the parent class only. Then it executes the output, always add function in base class, sum function in base class, add function, sum function in base class only. The control does not execute this function. Means the control unable to reach these functions in child class. But when we use the virtual keyword, then the control goes to the child class and it will verify the add function. If it is there, then it will be displayed on the monitor. So, the same concept is used here also. the two objects are created, object 1 and object 2, and a pointer variable is created for the base class only. Now, the first object 1 address is copied into pointer. By using this pointer, we are calling the add function and sum function. First, add function means it goes to this function and it executes. This is add function in base class. Next, we are calling the sum function. Then it goes to sum function and it executes. This is sum function in base class. Next, we are copying the object 2 address in a pointer variable. Now, by using that pointer, we are calling the add function. Now, the control try to goes to add function in base class, but the control does not execute this function because it is declared as virtual. Then it verify the same function in child classes. If it is there, then execute that function. Now, this is add function in derived class. This is add function in derived class. Here we are getting the output derived class function, add function output. This is add function in derived class. Next, it calls the sum function. Then it goes to this sum function in base class, because here the sum function is not a virtual function. So the control, it goes to directly base class. Even though we are copying the object 2 address in PTR, the control, it execute the base class function only. That's why here we are getting this is sum function in base class. Here, why we are getting this add function in derived class, the sum function in base class means this add function is declared as virtual in base class. That's why the control does not execute second time. Okay, if we try to execute the same function a second time, the control does not accept it and it directly goes to the derived classes. That's why here we are getting the derived class output. So here we are overcoming the problem. Now, here we are getting this problem. So, always we are getting the base class output only. But that problem is overcome by using the keyword virtual. So, when we use the virtual keyword before the function, then it is called as virtual function. So, for this sum function, we are not using any virtual keyword. That's why we are getting the always base class output. This is called as virtual functions. So, here we can overcome the problems in function overriding by using the virtual concept. Now, this concept is called as runtime polymorphism. So, next topic is abstract classes. So, there is a continuation topic for virtual functions. Abstract class is a class that is designed specially used for base class. An abstract class contains at least one pure virtual function. Here, virtual function is different and pure virtual function is different. Virtual function means a function is prefixed with the keyword virtual. Means the function is declared by using the keyword virtual. That functions are called virtual functions. But here, pure virtual function means that function value is equal to 0. When we use equal to 0, then it is called as pure virtual function. If the class contains at least one pure virtual function, then it is called as abstract class. So, always we can use the pure virtual functions in base classes only. So, the abstract class is designed to be specially used as a base class. So, we cannot use it in child classes. A class with at least one pure virtual function is called abstract class. So, one pure virtual function or abstract function. The pure virtual function is also called as abstract function. If a class contains at least one pure virtual function or abstract function, that class is called as abstract class. So, when to use abstract class? Abstract class is used in situation when we have partial set of implementation of methods in a class. For example, we declared 4 methods in a base class, but we have defined only 2, but remaining 2 we had to explain in the derived class. So in that cases, okay, we had to use abstract classes. For example, if a class has 4 methods, out of 4 methods we have an implementation of 2 methods, we need to implement 2 methods in derived class. In that situation, we can declare the 2 methods in base class, so that 2 methods are, if the 2 methods are pure virtual functions, then that are called abstract classes. So what are the characteristics of abstract class? We cannot create an object for abstract class. The objects cannot be created for abstract classes. Remember this point, because it contains partial implementation of the methods. Means when we observe this example, out of 4, only 2 are implemented in abstract class, remaining 2 are implemented in child classes. So that's why we cannot create the object to the base classes. A abstract function does not have body, means we are not implementing that function in that base class. That function is implemented in the derived class. We must implement all abstract functions in derived class. So when we use the abstract classes, that abstract class contains at least one pure virtual function. That pure virtual function does not have any body in the base class. That virtual function can be defined in the child class only. So what is pure virtual function? A virtual function value is equal to 0, then that virtual function is called as pure virtual function. A pure virtual function is a virtual function in which we need not to write any function definition, and it is initialized with 0. So just we can declare the function name with the keyword virtual, and that value is equal to 0. This function does not have any body, any implementation is not there in the present. So a virtual function will become pure virtual function when you append equal to 0. Okay, without 0 equal to 0, it is called as virtual function. So when we use the equal to 0 for virtual function, then it is called as pure virtual function. The pure virtual function does not have body or implementation that are implemented in the derived classes. Now this is the example for abstract classes and pure virtual functions. So class A and class B, A is parent and B is child. Here we are using the single inheritance. Now this base class, it contains 3 functions. First one add, second one sub, and third one multiplication. So when we observe this program, so virtual void add equal to 0, virtual void add sub equal to 0. Now these 2 are called as pure virtual functions. Pure virtual functions. When the class contains at least one pure virtual function, then it is called as abstract class. So the pure virtual functions cannot be implemented in that class. These 2 are implemented in the base class. Add is defined here and sub is also defined in the child classes. So here we are using the only declaration that virtual functions are equal to 0. We are not implementing here. For implementation of these virtual functions, we had to use child class. So next, multiplication. It is not a virtual function. It is a normal function. Here, that's why it contains function definition. Now child class is created. It is implemented from the inherited from base class A. Now these add and sub, these 2 are defined in this base class. So here in inheritance concept, always the object is created only for child class. So here the child class is B. Now B object obj dot add, it calls the add function. This is add function in of B class. Here we will get the first line output. Next we call subfunction by using the same object. Then we will get this output. Next obj dot multiplication. Then it directly goes to multiplication from the base class. Here we will get the third line output. Here when we observe clearly, so there are 3 functions in the base class, but 2 are not defined. These 2 are defined in the child classes. These 2 functions are equal to 0. That's why these are called pure virtual functions. If the class contains at least one pure virtual function, then it is called as abstract class. So this is the concept of abstract class and pure virtual functions. This is the output. Now, these are the references. Thank you.